Hello. Um, yeah, my name is Michael Serdyuk, and uh, a short story of my life, programming life. I've started writing Java ME games. We were writing clones of casual games like Lines, Zuma, and something like that. But we had no working process whatsoever, so we didn't have any senior in our team, and it was awful. So then I was started looking into other places, and I started learning Ruby. Ruby turned out a great language, as you all know, and then here I am. I was writing some blogs. Well, they were not actually blogs, but applications on Rails, like all of you do. And now I'm working in that art, and somehow I got to lead a team. We have a good project, and there's NDA, so I can't talk a lot about it, so I'm going to talk about other things. However, I suffer from imposter syndrome even more, so sometimes I think that they will just fire me for being me. But more interesting question is, how did you get here? I would like to ask a question. How many of you did want to write games when you wanted to, when you started programming? Okay, yeah, that's what I was thinking. I was in the same situation too, but in general, we all get to programming because we have some our own desires, and we let me go back here. I certainly had some hints. So yeah, you wanted to do cool stuff, earn money, or just to keep math in school. However, in any case, I think all of you want to be a better developer of some sorts, writing better code, and this leads us to two important questions. First one is being, why do we write code? And second one is, for whom the code is written, for whom do we do it? And I would like to start with the second one. Give it a thought for a moment. It may be something along these lines. Maybe for stakeholders, for project manager, for customers, for hardware, where this code will be ran, something like that. But what I'm actually saying is it's wrong. Not really wrong in the terms, all of those receivers do really need your code. Like, customers want to see their project going on, hardware is going to run it, but actually none of those really care what the code is. Machines on which the code is ran may be fine with some assembler lines or something like that. The customer really wouldn't care if, the bunch of people were just sending HTTP responses every time you send a request. What matters is running application. So my point is, the code is written for another group of people, and those are at first your colleagues, because they are the ones that are going to read it, they are the ones that are going to work with it. The second group is you in the future. I believe every one of you has encountered a problem when you see your code and you understand that, it was written by some other person, because it's generally what the things are. So if you don't write your code good, you will suffer in some different ways. And of course, new people that will come to the team that are unfamiliar with the code base, unfamiliar with some concepts you have there, and it's just new people, and you have to have a great process there. So the question, having this in mind, you already know, so the code is written for people, for you and for other people you're working with and you're going to work with. So my question is how to write code, good code, having this in mind. And as we had just this conversation in open talk, I just summed it up, but I'm going to repeat that. You have to be open to new ideas and new things. So I'm interested in other professions because I think they can give us a lot of insight, like architects or designers in this case. And I guess the designers have a pretty much they have a good amount of concepts that we can reuse then to get our code base better. And these are these things. I don't call them principles because they sometimes overlap, and I don't think that this is a complex or a fully covered system, but well, they are what they are, and I'm going to talk about them, and maybe some of them will give us some thoughts. So first one being feedback. Feedback is showing what happened and providing navigation and explaining results. And in terms of design, it means something. I'm sorry for the graphics, I was drawing it myself, but it's something like when you see a button and a bulb and you press on this button, you see a bulb lightning. So you immediately see what happened after you've made some action. And into programming, it translates like this. And I want to apologize for examples like people yesterday said it's very hard to come up with the example because for a presentation, because you get some special kind of brain freeze when you're trying to come up with something explanatory. What I'm telling here is when you're using some library, you're writing some code, and then it goes like this, and you're calling some long and not obvious function, and what you get is nil. It's a bad example of feedback. You don't know what the code does. You don't know what should it be doing, what should it be executing or something like this. And well, there are plenty of problems in this example, like naming variables in a single letter, or in general problems of good naming. And another continuance of this example, you go into login and you just see some unexplanatory number, and you just don't get what's going on. So I guess you have to provide good feedback in your code. And in terms of getting good feedback in code, I think the best advice is just choose good names. And you've all have done it, but if you're doing this is great. Okay, you should return useful results from your functions. You should return useful results from the libraries you're using. And of course, write good logs. Okay. So the second principle is consistency. Consistency is something about having similar things all over the place and keeping people from surprises. So you generally do not get an. Okay, so in design, it's something like this. You have buttons that look all the same. You have links look all the same in web design. And you know what's going to happen where you are going to use the same elements. And the same goes to the code. Here is an example from Scott Mayer's talk, and it's about C standard library. So it has these functions. We don't have to dig into what's going on in them. It's just they have file pointer as the first argument. And he said it would be okay if they all were like this. But there is another set of functions that have file pointer as the last argument. So this is confusing and inconsistent. And that is something you certainly should avoid in your code. So to keep code consistent, you have to, of course, keep parameters in order. If in one place you send a model first and then last, and then maybe like a keyword argument or something like that, it's not necessarily bad, but it's confusing. And while it's confusing, it takes time for people to understand and process it. So another advice from the talk I just mentioned, and when in doubt, you should definitely look in other places for inspiration. If you know, like for example, if Rails does this way, there is no need to invent your own way. You can always reuse what is already done. And of course, choosing good names is also something about keeping the code consistent. So you already know all of this. And as for the sign systems, it's something about having common alphabet and using existing libraries and maybe using patterns. So sign systems is something that we encounter every day. It's our languages, no signs on the street, or maybe just abbreviations we meet. And my point here being, people usually go into saying that we all need to use some kind of patterns, that we all need to come up with the idea, that we all should, for example, decorator, and that is a must, or we have to believe in something Django 4 says without questioning this. And maybe you all know this example. This leads to this awful Java code. I don't think it's awful. I have never used it, but it sounds really scary. Abstract singleton, proxy factory bin, and like that. So my point here is, like I already said, we're writing code for people we're working with. So this is not necessarily bad. You can use patterns or abstractions or whatever you call them. You may extract some code and business logic into some objects. But I think what you have to do is you have to come up with ideas together, because it's people who are you working with. It's something you have to agree on. So you have to speak with colleagues. You have to decide on common alphabet. You have to write it down, so you have an agreement for new people that come to and then it all will be great. So the next one is robustness, and I guess the naming is kind of bad here because I was maybe it's more about thinking forward, and there is the story about a pit of success where you have to keep usually people keep falling into pit of failure, so they do something wrong and they end up into the places they don't want to be. And pit of success is something when people don't know how to do something and they're trying to do, and accidentally they're in the right place. So there is this picture about how it always goes in the development. You just start with the clean new place and Rails new application, and then it goes something like this. By the way, when I found this picture on Reddit when I was searching it, it's an old one, but the comment was, "Oh, I see you're doing microservice architecture here." I guess you have to think forward while developing and designing your applications and thinking about what's going next. And this next diagram, we've seen it before. It was yesterday on some talks. It was about microservices, about using gems, but I think it's generally more applicable. The green flat line is something you design in the beginning. So the red line is developing applications as it goes. You always have this gap in the beginning when it goes faster, and in general, it goes faster and easier to develop when you don't think and you just write some code and throw it into the application. But eventually it gets to the point when maintaining this kind of approach is hard. So if you think in the start and then you plan it, and it all goes hard in the beginning, but eventually it will pay off. So, modularity, and it doesn't come in a natural way. It doesn't. It does require planning, but I think the planning is what you have to do if and only if you're going to reach the spot. If you don't intend to, you can go with the red line, and it's totally fine. So to keep that, it's just do the same. Don't hesitate to plan and to implement something you're going to reuse, and keep legacy in mind, so that won't so that it will work fine. So the next and the last one is affordance, and affordance is a concept I will show in the next picture. But the concept is you have to show how to use something, and in terms of code is writing good documentation and something like this. So in design, affordance is something you see and you know how to use it. For example, in this cup, you know that you can hold it by the handle and drink your coffee from it. You know you can open the door, or you know you can deploy your project. And all of those are affordances, or something you see you can use to get desired result. So if you don't provide good affordances, if you don't if you don't explain people how to use something you've done, you're ending up like this. For those who don't know, this Demon Souls, the first game of the Souls and Soul series, and its main idea is you have to learn by dying. It's not a game with a bad design, but however, no one will want to learn your code by dying. No one will have to learn your code by failing. So to do this, to provide good affordances, you have to write good documentation. You have to provide examples of how your code is used. You have to provide tutorials for those who are going to use it. If you're going to write some external library, but even if you don't, if you write some new project, you just have to provide documentation for the new people in your team. You have to provide an easy start so people come into your team can dive in and start quickly. If you're writing an external library, you just give a snippet of code that should be working right away so the people can get a good start. And also to give affordance, you have to give everything that we've already spoken about. You have to have a good feedback so people can learn by experimenting, so they can see what's working. You have to provide consistent code so that not many unexpected confusions. So you have to agree on some common language, and you have to think forward. So that's it for the writing code. So you just have to have in mind that it's people you're dealing with. Well, also machines, but for the machines, some other people will tell you about this. So another question is, why do we write code? And it's there are a lot of things we can make up, but also I think what we have to do is remember that we're not writing code for the sake of the writing code. We are writing code to do things, so we don't have to we don't have to invent bicycles. We just have to create stuff. And while doing that, we have to remember it's people we're talking with, we're dealing with every day, and we have to do good things for them and for ourselves alike. So that's it for my talk. Thank you for your attention. There are a bunch of links, and the time for questions, if there is still time.
There are no questions, I think. We have. Sorry. In microphone.
There are
How many people are there in your
people,
team?
8 or something like that. Yeah. So, yeah, we struggle without some of those things. We do certainly need some documentation, but it's how the life goes.
Mm-hmm. Often Ruby developers, when they are creating some external library and for common use for all developers, they are not providing documentation. They think that you should read their Ruby code, and that's it. What do you think about it? Is that a problem or not?
I don't think that's a problem. It may be an approach, but the things I've spoken about still have to be kept in mind. So even if you're encouraging people to read your code because you think it's self-documented, you still have to stick to the right name, and you still have to provide a good feedback use so people can play with your library at first. And of course, one thing they absolutely certainly should provide is a good start for you. So even if they don't write extensive, comprehensive documentation, they still have to give at least some snippet of code people can see on GitHub, project page, and type into and get this thing running, even if they don't understand all concepts of your magnificent library. You still, you still have to keep in mind new people. that won't dig into your library unless they have intensive to do so. Intention, maybe. Yeah.
Okay, thanks.